Okay. Perceive service. Okay, so thermal properties of matter. So in this chapter, you will be studying what is heat, what is temperature, then ideal gas equation, Boyle's law, Charles law. Heard of those laws? Ah, so you know, right? In chemistry, you studied. Okay, then then you will study different methods to measure temperature, different scales. Which all are the scales? Celsius, Kelvin, Fahrenheit. Then interconversion, like 100 degree will be what in Kelvin and Fahrenheit, like that. Interconversions are there. Then after that, you will study a topic called thermal expansion. Like in mechanical properties of solids, we studied on applying force, change in length, change in volume, change in area will happen. Stress and strain we studied. Here on applying temperature, change in length, change in area, change in volume. That we will study in this chapter. And then after that, you will study a topic called specific heat capacity. C. Molar specific heat is C. Okay. What is specific heat capacity? Amount of heat required to increase the temperature by 1 degree. That is specific heat. What is molar specific heat? It is the amount of heat required to raise the temperature of 1 mole of a substance by 1 degree. That is specific heat and molar specific heat we will study. Then we will study a topic, new topic, calorimetry. Heard of calorimetry, calorimeter?
I heard it.
No.
Oh, it is in practicals.
You are doing calorimeter? You are measuring the heat change or temperature change you are doing? Or just a theory you are writing? Theory. So you know what it is, right? You know what it is.
Bomb calorimeter.
So
There is a beaker like
so there is a beaker. In the experiment, there will be beaker. You are dropping some hot object to the beaker. There will be change in temperature, change in heat will be happening. You will be calculating that Q, right? Heat transfer Q. Okay. So that is actually what is happening in calorimeter. So we will study calorimeter problems basically. There's a procedure to do the problems. So if you study 2 problems, that is enough. Any calorimeter problem you will be able to do. But it's a lengthy steps. Lot of steps are there. Okay. Then after that, you have after calorimeter. Yeah. After calorimeter, you have specific heat. Sorry, you have latent heat. Latent heat, you know what is latent heat? That was there in 9th grade. There's a diagram also in the 9th grade textbook. This graph you remember? The temperature at which ice and water coexist, steam and water coexist, that is latent heat. Latent heat of vaporization. In chemistry, yeah. Latent heat of vaporization, latent heat of freezing. Okay. So that we will study. The graph we will study. And after that, we will do problems based on latent heat. Calorimeter problems are there, latent heat problems are there. And then after that, we will study different methods for transfer of heat. That is, conduction is one method. In utensils and all, it is basic conduction, right? When you heat it, the heat is getting transferred from one point to other point. So conduction problems are there. Then next we will study about convection. Convection. So convection means during daytime, land is warmer than sea. During night, sea is warmer than land. So that is because of the convection. Movement of air molecules. That we will study. Convection. Theory. Convection is theory.
Sea warmer than land at night.
Yeah, that is what we will be studying. Okay. Because of this air current. Then after that, we will study radiation. Then Newton's law of cooling. So everything is there in this. Everything is there. Okay. So here. Yeah. Okay, so here main problem is actually 3 mark problem is calorimeter problem, this conduction problem, heat transfer conduction problem, then latent heat problem. These main problems, these 3 are big problems also. Step by step you have to study. Then small problems are there. That is interconversion from Kelvin to Celsius, Celsius to Fahrenheit. Like that, small problems are there. Then derivations, Newton law is important. As I told you when we were studying waves or oscillations, that Laplace was there. Laplace correction was there, right? Same Newton's law is like also like that. Sometimes they will ask for 2 mark or 3 mark. Okay, so everything is there. Okay, in this chapter there is nothing deleted. So in 3 classes we can finish this chapter. Next Tuesday we can finish this chapter. Pooja, when is your exam starting?
Next week, Monday.
Monday. The main subject starts on Monday.
Yes, ma'am.
When is physics?
Tuesday. No, not
Okay.
Wednesday. Wednesday.
One day there is a break.
Yeah.
Okay. So, we can finish up to heat transfer, I think. That Newton's law will be pending. This week we can finish
Okay.
up to heat transfer.
Okay.
Okay. So we'll start. So first of all, first term, what is temperature? Give heading, okay? Chapter 10, thermal properties of matter. What is temperature? What is temperature? What is temperature? Yeah, from smaller ages you started.
The property by which heat exchange.
Hmm? What?
How hot and not.
Temperature gives the degree of hotness or coldness of an object. It's not anything about heat. Heat means it's a form of energy. Temperature is not a form of energy. Okay, so temperature gives an idea of the degree of hotness or coldness of an object. So, right. Temperature, it is a measure of yes. Temperature, it is a measure of degree of hotness or coldness. Temperature is the measure of degree of hotness or coldness.
And is this the proper definition of it?
Hmm?
Is this the proper definition of
Yeah.
a more advanced version?
Nah, in physics only this much is enough. Anyway, we are not studying going to.
Force we learned it as push up pull and then we figured out something else.
In chemistry, you might upgrade.
And in chemistry, with each topic, we keep upgrading.
What you learned to use that was false.
Okay, then heat. What is heat? What is heat?
One paragraph will be one definition. Next paragraph will be
No, that's
another
false.
definition.
No, firstly, this is false.
What is heat?
Boiling
And then
point.
psychology
Boiling point based
What
on
is
this, boiling
heat?
point based on
Oh.
that.
What is heat?
Energy.
It's a form of energy.
Yeah.
And it transfers from where to where?
Higher to lower. Yeah.
Higher, hotter object to a colder object. In
Higher.
terms of temperature, if you are saying. Okay, so right. It's a form of energy. Heat, it is a form of energy. Heat, it is a form of energy. It flows from heat is a form of energy. It flows from hotter to it flows from hotter body to colder body. Heat, it is a form of energy. Snigdha, it is a form of energy. It flow from hotter object to colder. The form of energy which flows from hotter object to colder. What's the unit of heat? Who's a Kelvin? Heat is joule. Yeah. Heat is joule. Now next, measurement of temperature. Next topic, measurement of temperature. How will you measure temperature? Yeah, using thermometer. Thermometer is used to measure temperature. What are the units of temperature? Kelvin, degree Celsius, degree Fahrenheit. Okay. What did right? Now we will draw a table, okay? Just to mention the freezing point and boiling point. Celsius scale, the unit is degree Celsius. What is the boiling point? Boiling point is 100 degrees Celsius. And freezing point? 0 degrees Celsius. Boiling point is also known as, what other name we have for boiling point? Steam point. Yeah, melting point or steam point. Boiling point or steam point. Freezing point or ice point. So in Kelvin, what is 0 degree? In Kelvin, what is the boiling point in Kelvin?
No, 370.
373.15 Kelvin. What about freezing point? 273.15 Kelvin. What about Fahrenheit? Yeah. What about Fahrenheit? In textbook, it is given as 373.15. It is given in textbook. What about Fahrenheit? Boiling point is 212 degree Fahrenheit. Okay. And this is 32 degree Fahrenheit. Freezing point is 32 degree Fahrenheit. Complete the table. And we'll write the relationship between among the three. So conversions you can use using the relationship. Okay, done, right? This much is done. Finished, right? Okay, so write the interrelationship. C minus 0 by 100 is equal to Fahrenheit minus 32 by 180 is equal to Kelvin minus 273.15 divided by 100. This is the equation showing the interrelationship between Celsius, Fahrenheit, and Kelvin. Yeah, Sahil. Yeah, it is 180. This is the formula for interconversion. Done?
What if it's -0
What? What?
What if it's -0 then?
No, I put it's standard formula. That's it. C minus 0 means it's C only.
See, it's okay.
Finished, right, all of you? Okay, next write the problem. Find the temperature. Find the temperature. Find the temperature which has same numerical value in which has same numerical value in Celsius and Fahrenheit scale. HEIT, okay. Sorry. HEIT, okay. Fahrenheit is HEIT. So for which value of temperature the numerical value of Celsius and Fahrenheit is same? That is a question. So equate C and F are equal for which value? That is a question. 2. Understood? For one particular value, C and F are equal. No, that is standard equation. You can that is C only. So these are actually the boiling points. 0 is the freezing point. 0 is the freezing point. In Celsius, 32 is the freezing point. In Fahrenheit, and 273.15 was the freezing point in Kelvin scale. So it will be easy for you to remember. Find what is the value at which C is equal to F. Yeah? C and F are equal, right? So put the same. Either C, put C for both. Yeah, correct, Sarvesh. No. For which value C is equal to F? That is the question. No. No. Yeah, Bhuja, correct. No.
By 180. I would have 30 by 100. Oh, it's 180. Okay. Yeah, I don't know. the one value.
The answer?
Minus 40.
What is the answer?
Why? What do you want to do?
Substitute
Yeah,
the
what is
fraction.
that?
Correct.
Okay.
What is the answer? Why so much of calculations? What is there to calculate in this? C by 100 is equal to F minus 32 by 180. 0, 0 cut. So C is equal to F. C by 10 is equal to C minus 32 by 18. So 18C is equal to 10C minus 320. 8C is equal to minus 320. C is equal to minus 320 by 8 minus 40. So C is equal to F at minus 40. That is the answer. Therefore, the answer will be C is equal to F is equal to minus 40. Yeah, do. Class 11. Yeah. Finished, right? Okay. Now, next question. Reading in Fahrenheit scale is Yeah, Grace. See, Grace, the question is that at which temperature C and F has same numerical value. So you have to take C is equal to F. That is the question. Okay. So write the question. Reading in Fahrenheit scale is 3 by 2 times reading in Fahrenheit scale is 3 by 2 times reading in Fahrenheit scale is 3 by 2 times the reading in Celsius scale. No. Yeah. So reading in Fahrenheit scale is 3 by 2 times the reading in Celsius scale. Calculate temperature in Celsius and Kelvin scale. Calculate temperature in Celsius and Kelvin scale. Calculate temperature in Celsius and Kelvin scale. Yeah, do. Yeah,
It's actually decimal.
what is,
Decimal answer.
yeah, it will be in decimal. Yes. What is the answer? What's the answer?
I don't know what it is.
Just normal calculation, mathematical substitution only. So here, Fahrenheit scale is 3/2 times the Celsius scale. That is what is given. Okay, so the formula is C by 100 is equal to F minus 32 by 180. So for F you can substitute 3/2 C. So C by 100 is equal to 3/2 C minus 32 by 180. So this will be 3C minus 64 by 2 into 180. Now cross. This will go. So 36C is equal to 30C minus 640. So 6C is equal to minus 640. C is equal to minus 640 by 6. You will get it as minus 106. 0.67 degrees Celsius.
What's the answer?
Minus 106.67. Come. Finish.
Oh, fish.
Hmm?
Maybe I can
Oh, you have to find for Kelvin. Do for Kelvin.
No wonder. I will take the right. Yeah. 5.3.
Okay, speak. Two down. This is numerical fault. I don't know. This is kind of fault. Right.
I couldn't say it. I just things you need right then.
Kelvin, you got?
Please see by minus 32.
No, keep it from there. No, keep it there. No, keep it there. You guys. The trial is the word, right? You go sit there. So you want phone, keep it there. No need of phone. Go right there. Go sit there. And go sit there. If you can't see. I told you
I
initially.
just can't see if you're on the laptop.
That is what I asked you. If you come sit here, you can see the whole thing.
I'll come with you.
106, 67.
Come. 1.02 minus. Finish.
No, no, see, we have to Kelvin. this. Yeah.
What is in Kelvin?
This one equal to.
Foundation.
Yeah, it should be.
Reading
That's
Celsius.
good, that's good. And zero slides.
What is the difficulty in the calculation in this problem?
Minus 6 or 3 by 6. 4,000.
We
Minus
we
106.67. Minus 106.
Anugrah, come sit here. Come.
Oh, yeah, 0, 100, right? Good job.
Okay, please.
Among that.
Action.
So in Kelvin, what is the formula for finding in Kelvin?
Action.
C by 100 is equal to K minus 273.15 by 100. 100 cut. So Celsius you already have. So Kelvin will be C plus 273.15. So C you already have minus 106.67 plus 273.15. That's it. That is enough, right? You did with the Fahrenheit itself?
379.8. No, it's not 670.5.
So it will be how much?
379.8.
Oh, minus and plus you will simply add. 166.23848 Kelvin. That's it. Understood. Anugrah understood.
How about the serious number?
Hmm?
I got 103.
Check the calculation.
Yeah, I did.
Finished, right? Finish all of you? Okay. What's the normal human body temperature?
That is on.
Hmm.
102.
What,
198 Fahrenheit. 98.2 Fahrenheit.
what is the normal human body temperature?
35 degrees.
35, 35, 37,
27.
27. Oh my god. Pooja.
Was that Snigdha?
No, Pooja. Snigdha is sleeping. No doubt, no answers. 33 to 37.
Anywhere between this range of 5 degrees.
Okay, you find. Temperature of normal human body is? Write the question. Temperature of normal human body is 98.6 Fahrenheit. Calculate in Celsius.
You're wrong.
Temperature of normal human body is 98.6 Fahrenheit. Find in Celsius. Now you will know. What? What iron?
Question mark for me.
Temperature of normal human body is? One point something and that is point something only. Okay. 300 minus 6400 it will be. You will get 40 by 6. That is. What do you want? This was. What? It was outside. Yeah. I kept it outside. I keep it outside. Yeah, keep it outside. Doesn't make any difference. Keep it outside. Yeah. So did you get? Do. Why you need that clip? Why you need that clip? In bag you can like a clutch.
Use it after he wants. Then still time I have
27, right?
37.
So that's answer.
It's 37, yeah?
Yeah. The normal human body temperature, are you getting it as 37?
Yes.
I'm sure it's 37.
38.5 up to that it is okay, you can manage without medicine. That is why I found from the thermometer. If it is 35.5, it is orange only. If it is 38.6, it starts alarming red color.
Yeah.
In thermometer, that
Yeah.
if it is above 38.5, 38.6 means it becomes red.
No,
Till 38.5, it is orange somewhat.
no. So when does a person die? No, like what temperature?
Okay, this is done, right? So are you all getting 37?
Yeah.
Buja, you got 37?
Yes, ma'am.
Okay, so you can use C by 100 is equal to F minus 32 by 180. So 18 C is equal to 10 F minus 32. 9, 8, 6 minus 32, 18, 6, 8, C, 4, 5, 9, 54 by 18. This is the answer, right? You'll get it as 37? No?
No, unit 666, yeah.
Yeah.
Ma'am, there's a decimal point.
That's 320. So this is 666?
Yeah.
No.
Ma'am, decimal point 8 is it?
666 by 18.
Yeah.
That is
33.
37.
37.
Okay. Okay, got it, right? Okay. So these are this type of interconversion questions that yeah.
How is it enough to basic?
Ma'am.
Yes.
How do you get heat? Okay, wait a minute.
Okay. So like this interconversion questions are there. Now next topic is you will tell me what is Boyle's law. You tell me what is Boyle's law. In chemistry it was there, Boyle's law, Charles' law.
No. Yeah.
I don't know which one. BOY-LES, right? What is the spelling? ELS or
Temperature is no temperature is
let me check the spelling.
Equilibrium thermometer or something. When I didn't study this.
Pressure.
BOY-LES, okay. Boyle's law. So right. At constant temperature, at constant temperature, at constant temperature, at constant temperature, volume of a given gas, volume of a given gas is inversely proportional to pressure. Is inversely proportional to pressure. So volume is inversely proportional to pressure, or you can write V into P is a constant at constant temperature. This is what Boyle said. This is Boyle's law. Now next is Charles' law. What is Charles' law? Any idea?
It's probably some contradiction to.
I was just talking about politics, Sandy.
Charles' law. At constant pressure, temperature is directly proportional to, volume is directly proportional to temperature. At constant pressure, volume of a gas is proportional to temperature. At constant pressure, volume of a gas is proportional to temperature. That is, V is proportional to T, or V by T is a constant. That is Charles' law. Okay. Clear, right? Now, when you combine these two laws, you will get ideal gas equation. What is ideal gas equation? PV is equal to nRT.
I know that.
Okay. So when you compile PV and V by T, you will get PV by T. So on combining these two, you will get PV by T is a constant. I'll tell you. Okay. So next you write, on combining these two laws, we get, on combining these two laws, we get on combining these two laws, we get PV by T is a constant. PV by T is a constant, or PV is equal to nRT. What is N? Number of moles. What is R?
Gas constant.
Universal. What is its value?
8.314. 8.314.
8.31 joule, Kelvin raised to minus 1,
Or 8.
mole raised to minus 1. This is the value.
Now what this another one? 0 something. It's in different.
So PV by T is a constant, or you can write PV is equal to nRT. So N is the number of moles and R is the gas constant. So this is known as ideal gas equation. This PV is equal to
NRT is.
N and R are constants, right? So PV by T is a constant, that you take T to the side, NR is again a constant. So this is ideal gas equation. What Kelvin, joule, Kelvin raised to minus 1, mole raised to minus 1.
0 values in which unit for power.
Textbook only touches you, man. Let's see. One form which I kept here is missing.
Summer comment.
Next is absolute zero temperature. This is okay, right? Absolute zero temperature. Next. Give heading. Absolute zero temperature. What is absolute zero temperature? Not studied in chemistry? Not studied. Absolute zero temperature. Any guess?
I'm asked.
Huh?
Children.
It is the temperature at which
Children.
the volume or pressure of the gas becomes zero. Okay. It is the temperature at which the volume of a gas or pressure becomes zero.
Means it's not there.
We can compress it, right?
But volume zero, you can.
Yeah, approximately. That is it's a concept. So right, absolute zero temperature. Absolute zero temperature, right? Definition. It is the lowest temperature at which it is the lowest temperature at which it is the lowest temperature at which gas is supposed to have zero volume or zero pressure. Zero volume or zero pressure. It is the lowest temperature at which gas is supposed to have zero volume or zero pressure, and at which the entire molecular motion stops. And the entire molecular motion stops. And the entire molecular motion stops. Give me the text. And the entire molecular motion stops. Okay. Zero Kelvin.
Oh.
So, no, one minute, okay. Let me check the graph whether it is Kelvin or degree Celsius. 1 minute. It is degree Celsius, okay. 0 Kelvin it will be. So this is a graph. So this is absolute zero. Absolute zero means it's 0 Kelvin. 0 Kelvin or minus 273.15 degree. Okay, so minus 273.15 degree at that particular temperature, the molecular movement is supposed to be zero. There is no movement. The gas, normally gas will flow, right? There is no molecular movement will not be shown. That, that is supposed to be absolute zero temperature.
Then, it is the temperature at which volume is zero
Volume or pressure becomes zero.
or pressure is also zero when temperature is at the lowest and the molecular motion starts.
Yeah. Finished, right? Yeah, draw the diagram. It's there in the textbook. All the graphs are important, okay, in this chapter.
Volume is zero, then there is no.
It is an assumption. supposed to be 0. Can never be 0.
So then just matter.
Okay, done, right?
No.
Now next topic, thermal expansion. So under thermal expansion, you will study 3 topics: linear expansion, area expansion, and volume expansion. What is linear expansion? What is linear expansion? When the temperature increases, initial length is L. It changes to L plus delta L. Right. On increasing the temperature, length changes to L plus delta L. That is linear expansion. Second type is area expansion. What is area expansion? Yeah. If this is area A, on increasing the temperature, area becomes A plus delta A. Correct? That is area expansion. The third is volume expansion. What is volume expansion? Yeah. This is initial volume V. So it becomes V plus delta V. Volume increase to V plus delta V. That is volume expansion. Understood? So these are the 3 types of expansions. Okay. So in linear expansion, you can write change in length by original length is proportional to temperature. It's proportional to change in temperature. Correct, right? As the temperature changes, this is happening. Okay. And in order to change the proportionality sign, we will put a constant that is coefficient of linear expansion, alpha L. Understood? Here length is increasing. Change in length by original length. How much change is happening is depending on the temperature. More the temperature, more change will happen with respect to original length. Okay, notes I'll give. Okay, wait. Now, so in order to change the proportionality sign, I'll put a constant delta L by L is equal to alpha L into delta T. What is alpha L? Coefficient of linear expansion. Understood? So alpha L is coefficient of linear expansion. Understood? Now similarly, you will do for area expansion. So in area expansion, what you can write? Change in area by original area will be proportional to change in temperature. Or you can write delta A by A will be equal to alpha A into delta T. Correct? So this will be coefficient of area expansion. Now the third one is volume expansion. Here, change in volume by original volume is proportional to change in temperature. Change in volume by original volume will be equal to alpha V into delta T, where alpha V is coefficient of volume expansion. Understood, right? Okay, so these are the 3 types of expansions. And very important derivation, the relationship between alpha L, alpha N, A and alpha V, that we will do. This you understood, right? So give heading thermal expansion, first one linear expansion. Give heading thermal expansion. Did you write any note below thermal expansion? No, thermal expansion, below you write the definition, okay? When the temperature, thermal expansion you wrote, right? Below that, just one sentence. When temperature increases, below thermal expansion you write, when temperature increases, dimensions of object change. when temperature increases, dimensions of object changes. And it is known as thermal expansion. And it is known as thermal expansion. Done?
What is ice even considered thermal?
Ice,
Water freezing, sorry.
water freezing.
Into ice takes more space. Water.
Yeah.
Thermal
Volume expansion. Okay, so when temperature increases, dimensions of the object change. This is known as thermal expansion. Yeah, change in temperature. Okay. Now, next you write first one, linear expansion. No, like that we will not consider because that is liquid to solid, right? Change of state. It we will not consider. In the same state, in the solid things, we are doing this. Expansions in case of solid substances, dimensions of an object.
So if ice does not completely melt, but kind of melt, it becomes small.
But it is not solid then, right?
No, it'll remain solid, but then part of it is liquid.
Inside it will be liquid. Yeah. Okay. So right, first one, linear expansion, right? When temperature increases, when temperature increases, when temperature increases, length of solid increases. When temperature increases, length of solid increases. This is known as linear expansion. This is known as linear expansion. Write the equation. Write these equations, diagram equation. Similarly, you write area expansion. What will be the definition? When temperature increases, area of substance increases, that is area expansion. Okay. Have your parent please? No. You'll go by bus only, right?
Yes.
What time is this?
I know.
Huh?
I was just telling you.
Yeah, what happened? You write the equations. All the equations you should write, okay? Diagram and equation. Definition, only linear is enough, right? For area, what will be when a temperature increases? Area increases, that is area expansion. When temperature increases, volume increases, that is volume expansion. Definition is okay. We need to do the derivation, that's why. We need all the equations.
Can you only like for same state expansion?
For
So, like,
solid.
so now is there a part where they'll show for solid to liquid or
No, this is for solid only.
in this chapter?
This topic.
Oh.
Finished? Area definition. When temperature increases, area of an object increases. Finish?
Yes.
The volume same thing, but volume increases, right? Instead of.
Yeah, everything it is increasing. On increasing temperature, volume increases. On increasing temperature, area increases. On increasing temperature, length increases. All are expansion only. Okay, finished, right? Finished? Okay. Now, relation between the derivation is important, okay? We finish the derivation. Relation between coefficient of expansions. Relation between coefficient of expansions. Listen, concentrate, easy derivation, relation between coefficient of expansions. Okay. So, listen, what is linear expansion formula? Anagram, what is linear expansion formula? Delta L by L equal to delta L by L is equal to alpha L into delta L by L is equal to alpha L into delta T. Okay. Side, what is area expansion formula? Delta A by A is equal to alpha A into delta T. Now from here, what is alpha A? Somebody, what is alpha A? Alpha A, what is alpha A?
Alpha A is delta A by A delta.
A delta T. This is okay. This is equation number 1. Okay. Now, okay, you can see, right? Okay. Now, how will you find change in area? Delta A, how will you find? See, this is a square. Area 4 meters square. This is another square area 6 meters square. What is change in area? 2 meters square. 6 meters square minus 4 meters square. So, how will you find delta A? Side into the side into side of this one minus side into side of this one. Correct, right? Okay. See, delta A will be equal to L plus delta L the whole square minus L square. Isn't it correct? Because the final side was, listen all of you, final side was L plus delta L. The initial side was L. So you can find delta A by final area minus initial area. Correct. Okay. So for next derivation, you will be doing the same with volume. Volume is what? Side cube. You will take a cube. Side cube is volume. So L plus delta L cube minus L cube. That is the only difference for finding volume. Okay. Only that step will change. Rest all the steps will be the same. Okay. So change in area. And how will you find change in area? Delta A is equal to? Listen, okay. I'll give you time for writing. L plus delta L, the whole square minus L square. Okay. Now A plus B the whole square, how will you do? A square plus 2L delta L plus delta L square minus L square. L square cut. Delta L square, you will approximate it to 0. Why? Because 0.01 square is what? 0.0001. So for a small value, if it square it, it will become even smaller. Okay. So what will happen to delta L square again? What will happen to delta L square? Listen, delta L square, you will take it as 0. Okay. Because delta L is 0.01. Delta L square means 0.0001. It is becoming even smaller. So that small value you can neglect. Okay.
So delta A will also become 0.
Delta?
Delta A will become 0.
Where is delta A?
No, because
Delta is square. This is delta L square, right? Delta L we are finding. Delta A is what we are finding. So what you will get finally? Delta A is equal to 2L delta L. Okay. You will substitute this in equation 1. Okay. Samati, you can see substituting 2 in 1. So you will be doing substitute 2 in 1. So here alpha A into delta T will be equal to, for delta A you will substitute 2L delta L divided by A. Okay, correct, right? A is L square. A is L square. A is L square, right?
Yeah, correct. Only.
Yeah.
So you will substitute here, right? Alpha A is equal to, in equation 1 is this. Alpha A is equal to delta A by A delta T. A into delta T. Correct, right? Yeah, correct. Now A is what? L square. Area of the initial square is L square. So 2L delta L, L square into delta T. L square is gone. So alpha A, what you will get? Alpha A is equal to 2 times delta L by L into delta T. What is this? This is alpha L. Alpha L will be delta L divided by L delta T. So you will get alpha A is equal to 2 times alpha L. Okay. Now next is alpha V is equal to 3 times alpha L. That is the next derivation. Okay. This one you understood? Write this, then you will do alpha V.
It's all in one minute.
Yeah, all in one derivation. What we need to prove is here, what we are proving is alpha L is 2, alpha A is 2, alpha V is 1 is to 2 is to 3. That is what we are proving.
Okay.
That is what we are proving. This much is okay, all of you? Right. Understood? Anugrah understood. Farsin understood? Farsin? Grace?
Yes, ma'am.
Grace, is it clear? Snigdha? Yes, yes. Finish? All of you finish? Finish volume also? Ah. Okay. So now for a volume expansion, you will start what is delta V. So what is delta V? L plus delta L the whole cube minus L cube. What is A plus B the whole cube? A cube plus 3A square B plus 3AB square plus B cube. 10th grade formula, right? L cube plus 3L square delta A square B plus 3A B square plus minus L cube. So which all terms you will cancel? This
cube.
delta L square will be going to 0. Delta L cube also going to 0. Delta L square and cube, it will be 0. L cube minus L cube gone. So what you will get? Delta V is equal to 3L square delta L. Okay? Okay. Correct. So now, what is the formula for we have? Delta V by V is equal to alpha V into delta T, or alpha V is equal to delta V by V delta T, correct, right? Substitute delta V value. Delta V is what? 3L square delta L by delta V delta T. What is V? L cube. Okay, so this will become 3L square delta L by L cube delta T. What is that? 3 delta L by L delta T. What is that? 3 times alpha L. Easy proof, right? If you understand, it is easy. Otherwise, so you will get alpha V is equal to 3 alpha L. Okay, finish. Understood. So therefore, you can finally write this. Therefore, alpha L is to alpha A is to alpha V is in the ratio 1 is to 2 is to 3. This derivation is important. Bhuja, it is taken, right, Bhuja?
Yes, ma'am.
This is important. This is actually your first example question, 10.1 in your textbook. In this chapter, this is the first example question. In that, they derived only till alpha A, but alpha B also similarly you can derive. Equation is given. Clear, right? Okay. So first topic is over. There is one more topic. This that is anomalous behavior of water that we will study later. Next is actually specific heat capacity. Specific heat capacity, calorimetry, heat transfer also I'll try to take the theory. Calorimetry problem we will do. So next class is when? Thursday, right? So Thursday morning, right? We used to take it in the morning. Yeah, 10 o'clock, 10:30. 10:30 I'll keep, okay? 10:30. So I'll try to cover maximum topic on Thursday. Okay, maybe only Newton's law will be pending. Okay. Okay then. Yeah. Bye all of you. See you next year.
Thank
Happy
you,
New
ma'am.
Year.